All right, we're back. Welcome back to Lag Programming and Compiler Design. Where we left off, we decided to hold off the let statement to the next video, and that's what we're going to work on next. Let me take a quick look at my notes just to make sure that I get this correct. My mouse wheel's a little bit noisy, I know. Here we go. Okay. One of the things I'm going to do is, this is a little bit annoying, trying to do these printout statements in this. Real quick, I'm going to go eliminate them. I'm going to eliminate it from here. We don't need this. And I'm going to take out all of them from here because we're going to use a visitor to do that. That will have access to everything that it needs to print things out nicely, and that'll simplify our classes here, and we won't have to try to mess around with recreating these. So we'll just have this except function will be the virtual function that we need. I'm just gonna get these out. Just a little bit of redesign. This gone. Okay, now for our let statement, we will still need our virtual visitor function here, and we need a public section. And so a let statement has an identifier. It has a list of statements that are just a list of nodes, so it's a node list, and it has a parameter list. So the parameters are the things that we're telling it that it can pass into it. So let's create these. Standard string underscore ident. Okay, and then did we create a node list type def? Let me tighten this up a little bit. It's a little bit sloppy. We need a type def of a vector of fng node, and we'll call it a node list. Okay, so the next thing we need here is a parameter list. This is going to be a pointer to a parameter list underscore params, and then we need a node list pointer, which is going to be our nodes, the things that the function has within it. So, and that's the code that is this function. It's whatever nodes make up this complete function, which can be other let statements or expressions and so forth. So then we need our let statement, and it's going to take its ident, a parameter list, and a node list, a pointer to a node list, nodes. And so then we just fill those in, underscore ident, underscore params, and underscore nodes. There we go. And we've got our let statement. Now we might run into an issue here on main. Let me double check it. Where is main on this game? We're just parsing it, so it shouldn't matter. Let's do a build, make sure. Oh, we got something wrong. everything somehow became abstract. I thought I removed. So what did I do wrong here? I took out from node. Oh, I left this in node. There it is. Okay. I left node with that one extra abstract method, which I took out of everything else except out of the node. Okay. So we're good. So we go back over here, our parser, and where's our let statement? Okay. So it can be just an ident assigned body, or it can be an ident with a parameter list and assign an assignment and body, which is an equal statement. So let's do this one first. Let statement has to be of type let statement, so we can go in here and go let statement pointer let statement. We have to assign the type to that non-terminal, so percent type let statement. All right. And I believe that line will have to be a node. Did we assign line yet? And do we have a node? We don't, so let's go ahead and add these in. FNG node pointer is a node, and FNG node list pointer is just a node list. We're getting very close here. Let's go percent type node is a line, and percent type node list is a program. A program is a list of nodes. All right, we should be able to, and then we have to have a statement list. A line is a statement list. A statement list. We have to assign these. Body is going to be a node list. Yep. Body. Yes, body will be a node list, and statement list will be a node list. So we've got node list, so this is going to also have body and statement list. All right. So if we've got a statement list, we need a new node list. $$ equals new node list, and then $$ pointer pushback $1, and then $$ equals $1. That's the statement list. $$ pointer pushback $2. And then here we're just going to go that $$ equals $2. That'll move it out of there. Or it's just yeah, and then we have to do the same thing here. $$ equals new node list. $$ pointer pushback $1. That gives us our body. And then for our let statement here, we can say that $$ equals new let statement. And it's going to have an ident, which is $2. It's going to have a parameter list, which is $3, and a body, which is $5. Follow that? We ignore let. It's just there for syntax. The identifier is $2. The parameter list is $3, and the body assign is $4. We ignore it. $5 is the body. And here we go. $$ equals new let statement. And we put in the ident, which is $2, and the body. So $3 is going to be null pointer, and the last one is going to be $4. And then a line, we're just going to pass these up. $, equals $1. Say that $, equals $1. $, equals $1. Just passing them through. Error we will ignore. Now a program and a line. Okay. So here we would have to say if $1 equals null pointer $, does not equal null pointer $, equals $1, else, oops, semicolon, else $, equals new node list. And then we can do $, pointer pushback $2. See if I got that right. Got an error. Bunch of type errors. Let's see here. Does not name a type. FNG node list does not name a type. Surely it does. FNG node list pointer. Let's go back up here. I just called it node list. Let's change it to FNG node list. Some more errors. I just love tracking down errors. I'm going to do this so I can be sure to find easily the start of all this. There it is. Node list does not name a type. This needs to be FNG node list. This needs to be FNG node list. Make again. New FNG node list. Okay, warning. We'll address these warnings from the rules eventually. Pushback. program as a node list. Did I do this node list incorrectly? FNG node list. Ah, it's supposed to be an FNG node pointer. And another little error. See, it's so easy to make little mistakes like not making this public. Almost there. Node list again. Where did I say node list? This has got to be an FNG node list. This has to be FNG node list. And a typo. And what do you know, it built. So then we can go say game. I don't know where we're adding this. Are we even running our new compiler yet? I don't think we even tried to run it yet. Let's go to main. Oh yeah, we're calling funge and parse on the input file. So where did we build a yes, it's called test.fng. Segmentation fault, corrupt. Great. All right, let's see if we can figure that out. In fact, you know what? I'm going to pause the video for a minute and see if I can check out what's causing this segmentation fault, and I will be right back. Okay, I'm back. Yeah, the problem lay here in trying to actually admit this up to all the way up to program. This is really just a control structure, like a driver, and what we want to do is collect the information. And the way I did that was I created a new FNG node list up here, which is going to contain all the collected lines of our program as we get them. So each line that comes in here gets pushed into FNG nodes, and we'll be able to actually return that pointer from our function that we're going to put in here. We're going to move our main function for this over to this to a compiler for it, so we can access it. But we'll get to that later. For the moment, it does build, and it runs on our little test program. We get no output, no errors. And that looks like this. It's just got a simple let statement. Let's do another one. Let's go let test. Let's make it this equals a equals. I think we can do this and go let test2 a b equal a plus b. And we'll come down here and we'll go something like test2 1 2 and see if that gives us errors, and it does. Unexpected C parent expecting ident. Do this. Oh, that compiled. So we've got a let statement within a let statement. And in the next, we're running right up here on 20 minutes, I think, into this video. So I think we will close this here. We are compiling this simple bit of code. At least we're getting it without errors, and we should be producing a an abstract syntax tree now. We filled this in completely. Our parser now has all of its bits and pieces, at least for this first part, with working with expressions and let statements. Later, we're going to add in some data structures and some ways to define data structures and some things for working with data structures. But for now, this will be enough to get us rolling on showing how a language works. In the next video, what we're going to do is start creating a visitor pattern. And the first visitor we're going to create is going to be a pretty print visitor. And the purpose of that is going to be to show that our abstract syntax tree is being built properly and it can regenerate our source code and make it look nice so that we can see it and read it and compare it to our original source code. If we can regenerate the source code from a pretty print visitor, then we're confident that the abstract syntax tree is correctly capturing all of our program. So that's where we are. We actually have a basic parser completed for a very simple functional language that lets us set up let statements. There's one other thing that we will have to do is designate like an entry point for the program for the executable. We'll do that in another video as well. That'll be a simple way of, we'll figure out an appropriate way to identify it. Perhaps we'll call it main, like in C, or we'll call it whatever we want. We'll put some designator on it. We'll have a keyword like entry. And if anything tagged with entry means that that's the one entry point to the program or something along those lines. So that'll come about when we decide to start executing this, which we will initially do by producing some special execution objects. And these are going to be important because this little execution chain that we're going to make of execution objects will be also what we use to generate executable code for our JIT compiler. So that's it for this video. Thanks for watching. I hope you enjoyed it. If you liked it, hit that like button. If you really liked it, hit that subscribe button, and I will see you in the next video. Thanks for watching.